What's up, everybody? Doing a spontaneous Friday show with Danny, Matt. How's it going, guys?
It's going well. Good to be here.
It's nice to be in Salt Lake.
Yeah, it's good to have you here. We're at my house right now. Figured we'd just do a spontaneous chat about data. We're going to talk about what MLOps, data engineering.
Possibly random dogs walking through the frame. We'll see.
Yeah, possibly that too. So, cool. What's been on your mind lately? I guess for people who don't know who you are, do you want to also give a quick intro?
Yeah, I can definitely do that. So my name is Danny. I like rock climbing, long walks on the beach. Oh, wait, sorry. This isn't for my Hinge profile. So I studied computational statistics at UCLA, and then I started working at this big data platform called Cubal. And that's how I really got exposed to the world of data, machine learning. And one of the things that I realized is we were building a lot of tools for data scientists, machine learning engineers, for data analysts. But one of the gaps that I was able to identify with the tools that we were building at the time was that it was really hard to take these tools that were meant for building things and use them for making sure that these things were effective in production, right? Like taking it beyond just training a machine learning model or developing a data pipeline and actually deploying these things into prod so that you're starting to get value out of them. So with that in mind, I joined this company called WhyLabs that focuses on exactly that. We do machine learning monitoring, AI observability. We help people who are using machine learning applications and data pipelines to monitor and observe on their data so that they can run these systems with certainty.
That's cool.
Hi, Lana.
So I've got a dog here.
Yeah, she's in the shot. There you go.
And what do you do for a living there, Lana? That's awesome. So we hear about MLOps a lot and observability. Can you walk us through what these two terms mean? I think that there's still some people that might be confused.
Yeah, definitely. So MLOps is a really useful concept, but the term itself has only been around for a couple of years at this point. And what we did in the ML world is we looked over the shoulders of our friends in DevOps and the classic software 1.0, and we said, wow, you guys have really figured out how to deploy software applications in ways that are scalable and performant and robust. You've really figured out how to make this stuff work. How do we make it work for machine learning? Because as I was talking about earlier, one of the big gaps that we had in the machine learning world was you would build these things in the sandbox, but then how did you provide value for your business from it? If you weren't like a Netflix or a Google, if you weren't one of these really big companies. So that's MLOps, is basically taking a lot of these best practices from DevOps that were created for software 1.0, for normal software applications, and applying them to software 2.0, to machine learning applications. So that's MLOps. Any questions about that, or should we talk about observability?
How does software 2.0 differ from Web 3.0?
And what is Web 4.0? These are the real questions.
What's MLOps? I mean,
Yeah, this is pretty abstract.
Yeah.
Right? Should I get more concrete? Yeah.
Well, okay. I mean, let me ask you this too. So in your response here to the question, also relate it to data ops, because I think these are somewhat distinct, but they overlap significantly from my perspective.
Yeah.
I'd be curious to hear your take.
Yeah, absolutely. So I strongly agree that there's a ton of overlap between data ops and ML ops. So data ops is basically taking this exact same idea of wow, DevOps really figured a lot of this stuff out and applying it not just to machine learning applications, but to data applications more broadly, right? To data engineering pipelines, to machine learning platforms, to all of these things other than just the ML ops applications. And the reason that ML ops and data ops intersect so much, and the reason that it's so relevant to talk about both in line with each other, is that data engineering and the products of data engineering become the things that machine learning engineers consume, right? Data engineers create these data pipelines that can either feed analytical functions like BI functions or people who need to analyze data, or alternatively, these data applications data pipelines can feed into machine learning applications. So MLOps is really a customer of a data ops org.
That's a good way of looking at it.
That's interesting. Yeah, and from my perspective, you can tell me more about this too, but fundamentally, MLOps is going to care a lot about the quality of data, which is one of the things that data ops has added to the whole process. I mean, frankly, ETL development teams have been monitoring pipelines for a long time, for several decades. They've struggled a bit more on the statistical monitoring of data, like dynamic monitoring of data quality. And so to me, that's part of what data ops adds is okay, we need to monitor the quality to look for unexpected problems with the data that don't just show up because you get a logical break somewhere. Okay, I'm seeing more nulls here. Why do I see more nulls? My data, the pipelines still run, but I see more nulls. And then for MLOps, it seems like you add to that monitoring of models, for example, the products of the data. How do the models perform? Are they doing weird things that you don't expect that might indicate an underlying problem?
Yeah, I think that's a really good way to think about it. Like data ops went, and similarly in MLOps, in order to do monitoring and observability, we need to solve like a superset of the problems that people needed to solve in DevOps, right? DevOps would worry about stuff like latency, like response times, right? Like, is my server running? Obviously, like, if you're running an ML application, you care about how long it takes for your model to make an inference and how long it takes to serve a prediction. But you also have to care about the quality of that prediction, right? Because that's the really big difference between software 1.0 and software 2.0 is that software 2.0 is in some sense like more dynamic, like more stochastic. There's like less predictability in it. So suddenly you have to care not only about like the system running the application, but about what the application is presenting and delivering as well. And similarly with data ops, like, yeah, you need to make sure you need to like go to Airflow and like see that your pipeline is run every single day. But if your pipeline's running and it's introducing a bunch of nulls into the equation, then just monitoring that it's run is not enough. You also need to monitor the data, within it and monitor the metadata about that data.
And then in MLOps, you might, in addition, see the consequences of all those nulls. Like, why is my model really skewing? Well, it's because I've got all this null data. And then you go upstream and start asking questions about where the nulls are coming from.
That's absolutely right. And that's why when we talk about observability, which is kind of like the next step after monitoring, it's really important to be monitoring, to be creating observability artifacts, not only in the machine learning model, but really all the way back throughout your data pipeline. So that when it's time to debug some kind of data quality issue or some kind of data change issue, you can really like pinpoint exactly where the problem is. So I just threw out a word that Joe had previously asked me to define. So maybe we should dive into defining it a little bit. Yeah. So observability is like the new hot buzzword for MLOps in 2022.
Didn't notice.
Yeah, you might see a little bit of branding about it these days. So the idea of observability actually comes even before the DevOps revolution and comes with control theory. And the idea for observability is basically being able to monitor and to get insight into a system from its outputs, right? What's really important for observability, especially in machine learning, is the ability to look at the historical state of a system and to track these outputs of a historical state of a system so that you can see changes over time so that you can monitor for any kinds of problems. So monitoring is really like a subset of observability. It's like the tip of the observability iceberg. Monitoring will tell you when something has gone wrong, but won't necessarily tell you how to solve the problem. To solve the problem, you really need a fuller scope of observability. Is this too abstract, Joe?
No, makes a lot of sense to me. What about the audience? I'm very curious about thoughts on observability, kind of in general. But I think there's two camps too, it seems. I don't know if these are like artificial or what, but there's data observability, there's ML observability. And in a lot of cases, I'd say that there's a lot of overlap, but sometimes there aren't either. And how would you think about the distinction between data observability and ML observability?
Yeah, great question. So to me, ML observability is like a special case of data observability because like ultimately here's a dirty secret of the like ML monitoring, ML observability world. There is no such thing as ML monitoring. You cannot monitor a machine learning model. You can monitor the data about the model. You can monitor data coming into the model. You can monitor the predictions being made by the model, which are themselves a form of data. And if you have ground truth, you can monitor the performance of the model. All of these are just data. So really what you're monitoring when you're like monitoring a machine learning model is you're monitoring data. Now, there's some ways that, the data about a machine learning model is different than other types of data. It's a special case. So it's useful to have dedicated tools like WhyLabs that are specifically built for machine learning monitoring and observability. But it's also important to keep in mind that these tools generalize to solve more generic problems around data observability and data ops.
And of course, implicitly, when you're monitoring models, you need to think about the upstream, just like you were saying. You can't just monitor your models. You need to monitor everything that happens upstream. Because if you get, let's call it data breakage, like say a big, bot attack on your site, that can also mess up your model training or your model performance or your bids on ads or all kinds of other things downstream.
Yeah, that's exactly right. So in order to be able to like debug and really get value from observability has to extend beyond just monitoring the model itself and monitor all of the pipeline leading up to the model. And that's uncomfortable, I think, for a lot of other MLOps companies because they're like very used to the ML world and they don't necessarily have the ability to monitor like data warehouses or like message buses like Kafka. Like they don't have experiences with these more like data ops, more data engineering oriented tools, and are really used to focusing only on the like ML ops and machine learning oriented tools.
How important is stuff like lineage?
I mean, super important. Like, yeah, I think it's critical. I think lineage is like a component of observability to be able to see changes over time and to be able to track, where your data is coming from for exactly what we're talking about, to be able to debug issues in the pipeline.
Right. Yeah. Interesting. Tiago has a comment / he says, it looks to me the data observability issues before hitting the AI model itself is usually a bigger problem for the performance of the model itself. For example, a bunch of nulls. Yep.
Yeah. So I categorize this as kind of like two categories of problems. I call one of them data change problems. And that's like, it's really sexy to talk about like data drift and concept drift and covariate shift. Ultimately, what it means is like data is changing. And this probably reflects the real world changing, right? And that's one type of issue. And honestly, like ML vendors focus on this a lot, right? Because this is the problem that they are designed to solve. Is we want to be able to track drift and change over time to alert you when it's time to retrain your model. But Tiago, I think your point is completely valid that like the majority of the time when I see model breaks happen, when I see like absolute model failure, the cause of this failure was not data drift, but actually data typos, basically like data quality issues, which you're exactly right, are introduced upstream. So it's important to do both. And, you want to be monitoring your model because you want to see when something is breaking. But in order to understand how to fix something breaking, you have to be able to go back earlier in the pipeline.
The other point I'd add to this, and this builds on what Tiago was saying, is that even this basic, quote unquote, basic problem of monitoring data for logical flaws, that is things that just don't make sense according to input or business logic or what the app should be doing, that's still a really hard problem in the sense that I think very few companies are really getting this right now. There are tools out there, but it's a tough problem in terms of practical implementation in an organization to actually implement the monitoring and implement fixed processes that can react quickly when problems do arise.
Yeah, I completely agree. And I think like this is something that I've been thinking and talking and that we've been building a lot around is like automating the responses, exactly like you're saying, automating the responses to both data quality issues and data change issues. And this is like a pretty bleeding edge area in industry right now. I've been calling it auto MLOps just because I don't know like a better word for it. It's been pointed out to me that sounds too much like auto ML.
Or ML auto ops. But then it sounds like you're working on a car.
Yeah, that's a challenging one to name, but basically like trying to automate, because in DevOps, like you don't need SREs and DevOps engineers intervening every time you have a problem in your CI/CD pipeline, right? Like that would be ridiculous. You automate as much as possible.
What's the whole point of DevOps? Just
right.
Democratize it.
Automate. Yeah, exactly. And like, I mean, it's crazy, right? We exist at the intersection of the two things that are automating the most processes in the world, right? First, software was eating the world. Now machine learning is eating the world. So why aren't we using ML to automate a lot more of our ML processes? And that's a lot of what we're building over at WhyLabs, is trying to create the systems and platforms for people to be able to automate a lot of their responses to both data quality issues and data change issues.
We've been talking a lot about this too, Matt. It seems like I wish there was more attention paid to the sort of the source systems and the root cause of a lot of issues. Our buddy Scott Taylor, he'll always talk about master data and stuff. And I think it's a good notion. I think it's harder to do when you're talking about data that changes a lot. IoT data, for example, edge data, stuff where new JSON data too, or you might just add fields randomly, right? But how do you address data quality? And then unstructured data, I think, is the other one where that's probably leave that alone for a bit. But the data quality issues, though, I mean, I can see it getting a lot worse before it gets better. But I wish there was more attention paid to sort of the root causes of why these issues are introduced in the first place. Do you have any thoughts around that?
Yeah, I think that we're definitely like maturing in the industry, right? Where I can think back like 5 years ago, I was like manually writing tests on data pipelines, right? Where I would say like, okay, I know that there should be like about this many, number of rows in this data pipeline. Like I know that it should happen about this quickly, whatever, and like get alerted if something goes wrong. And then like Great Expectations came around and they like nicely packaged a lot of these tests that we were already writing. And that was like super awesome, right? And really, really useful. And then I think the next evolution from that is introducing more like intelligent anomaly detection, less need for human intervention to even like manually specify these tests, right? Instead of saying like, hey, I think this should have about this many rows. Like we should be allowing anomaly detection systems to figure out how many rows this thing should have. Because especially as like data and machine learning models scale, it becomes really impractical for a human being to do this stuff. So I think that's kind of where we are in the industry right now. And then I think we're both looking in the same direction, looking ahead at like automating a lot of these processes and doing a lot more root cause analysis on like what is introducing these problems. And I think we're getting better at it, to be honest. Like I do think there's like a lot of maturing happening in data and in ML. But it's definitely like looking at our friends in DevOps, I'm like, wow, you guys really figured out a lot of stuff. Really
they figured out a lot of stuff, but the applications still produce bad results sometimes too, right? Yeah. So it's like, I think what DevOps really figured out is how to make systems reliable. I don't think that they figured out how to make data reliable, and that's maybe you call it data ops. But again, I sometimes think we're looking in the wrong areas. It's like after it gets to the data warehouse or the model, it's like, cool, congratulations, you built a model on crappy data. And so, but at least I think the cool thing is this is being acknowledged as a problem now. Even a few years ago, it's like, I don't see a problem here.
Right.
It's more just, I think denial is the first stage of acceptance, as they say. So.
And inherently, data is very, very complicated, and it's just become more complicated since the web started, in the sense that more and more of your data. So I would say the 90s assumption in data warehousing is that most of your data is coming from inside. So you got an inventory tracking system, you've got accounting, you've got various people working on internal apps, and they're tracking all this data. Okay, so it's in your boundaries. It's hard to manage, but at least you have some hope of controlling that data. And then the web comes along, and more the assumption is that your data is from external sources. You no longer have that control. And so that can mean that, human actors are generating data that's weird by doing weird things on your website. Bots are doing weird things on your website, all kinds of external technology factors. Then you have, I don't know what's typical these days, but I would say for what I've seen is companies over $1 billion of revenue probably have at least 100 external data sources, probably actually a lot more than that. Mm-hmm. Any of those external data sources, external partner companies can be a source of data changes. It's technical debt that you don't control, right? So like when Google changes their reporting in Google Ads, which they do periodically, hopefully you notice, their release notes and things, but you might not. Then it screws up all your reporting. Totally. All of this makes, and I think DevOps started to embrace complexity and randomness, right? Because they are dealing with the outside world, but at least the software still sits inside your boundaries, which simplifies the problem slightly. Yeah. But now with all this data flowing in, you're dealing with other people's software applications. That's really, really hard.
It's super hard. Yeah, and I think one of the other like really important things to differentiate software 1.0 and what DevOps is dealing with and what we're dealing with is both the like internal versus external data, but also like the fact that fundamentally like the things that we're building are black boxes, and we can try with like all of these explainability techniques, and there's definitely like super cool, interesting research happening here, but like we're not close to understanding why a neural network makes the predictions that it does globally. Just like, to be honest, I don't know why Joe chooses to wear these glasses or like really understand, like we can't ask a neural network for true explainability when it doesn't exist in human beings either. But anyway, all this to say, like, I think there is like a fundamental, like a real qualitative difference between like software 1.0 and software 2.0 in this sense.
What do data engineers think about?
Oh man. Hopefully getting outside and like getting their exercise, sleeping enough. Highly recommend sleeping enough.
I would like that.
One thing that I see the data engineers that I talk with struggle with sometimes is ensuring data quality from like a very human perspective, right? And like, I work for a vendor, we sell a product. You guys are like a consulting company, like you help implement technologies and help people implement processes. And honestly, I think between the two of us, like you guys have a potential for a really big impact on the process side, which I think is hugely important because we can give people perfect tools, like amazing, incredible platforms. And dude, if they don't use it, it doesn't matter, right? Like
I see this a lot.
Yeah. So I think like as engineers, we focus a lot on tools and technologies. And I think it's really important for us as human beings to think about other human beings and figure out how to get human beings to implement the right processes and to act on the right processes.
Yeah, that's hard.
Yeah.
That's
why I leave it to the smart people.
That's interesting. I mean, you talk a lot about incentives, Joe. It's one of your favorite topics for good reason, I think. I mean, incentives are a big part of data project success or failure. I mean, especially where you're working across teams.
For sure.
To get the project done.
Yeah, incentives and outcomes. Wish Aaron was here right now. He'd be talking about economics. And so Aaron, Hans, go shout to him. He's on our team, but man, he's an economist by training. So every conversation goes a trade-off. It doesn't matter what it is. It's like, Aaron, would you like coffee or water? Well, let me see the trade-offs on this.
Some SWOT analysis on this. That's funny.
Like, oh, maybe in a Malthusian trap or something. So it's interesting. But yeah, I think a lot of things we always see and a lot of things we always talk about on the shows is, there's people, process, and technology, right? And we always look at things in that order. It's always people, process, and then technology. Sorry, my dog. There you are.
She has the wrong incentives.
She's, we could let her out.
Yeah.
Thanks. Sorry. It's unlucky. Sorry.
So I think the way that this ties into
Thanks,
like data engineering and what data engineers need to think about is like you need to think both about people upstream from you and people downstream from you. Right?
Yeah.
You need to think about who's consuming the data that you're producing, as well as think about where is this data coming from. And like Matt, your point about going across teams is really well taken, right? Because as organizations grow larger, they generally get more balkanized and like more specific into their role. And companies like Stitch Fix try to like go against this by having their like end-to-end data scientist. But ultimately, at some point, it gets really, really hard to like own an entire data and ML pipeline end to end and really understand all the way from like, how is my data being generated to how is my data being consumed?
Mm-hmm.
But I think that focusing on those two things and kind of incorporating even some like product management mindset into data engineering is really, really powerful.
Product's a big one for sure.
Yeah. And then, so in some sense, we're talking about cross-team product. And one thing Joe and I talk about quite a bit, and we talk about this in the book as well. This is more to do with application data, so not all these external data sources that we were talking about, but just better data integration between the sources, the applications, the developers who are creating data from users and from interactions with the analytics side. And traditionally, in this kind of data warehouse mindset, it's like, okay, over here is my application database, and over here is my data warehouse, and then in between is this layer of ETL, and I do all this crazy transformation and munging to the data. There's not a lot of communication. The app can change without changing the analytics. We keep arguing that really maybe the teams are separate, but the incentives need to be common.
Needs to be aligned.
Yeah, very common.
We think of it as the same data, which we kind of don't, right? We almost think of it as different data, even though it's the same data. And that misalignment is a huge problem.
Huge problem. I'd say it's probably one of the biggest problems that people face, is just making sure teams are aligned. Because from there you can get processes. If you don't have teams aligned, then it's kind of, I don't really care what tools or process you try to introduce for each team. It's not going to gel. So. And you get problems. That means like for vendors too, it means like lack of adoption or like, high churn because every team wants to do something different. And so there's a lot of issues with that too. Like resume driven development's a big thing. Right. Shiny object syndrome, they're kind of related actually. So yeah, it happens a lot.
I think one thing that's being talked about more and to some extent being like developed as a product, but I don't think this is like really well rolled out yet, is data contracts, right? Is having like an agreement between teams that is like encapsulated in a contract of this is what this data is, this is what this data represents, this is what this data looks like. And if the producer violates this contract, at least the consumer knows and is able to respond to this, rather than, like the ultimate like scare scenario on this is you've got some analyst who's interpreting some data that's going to the CEO who's presenting it to the board, and now you've just lied to your board and you've got SEC problems, right? So that's the very extreme scenario of what happens when you've got a miscommunication or when you've got a violation of a data contract. But at least if the analyst knows, like, hey, there might be a problem in this because this contract broke, that's a sign.
It's interesting too, because we're starting to hear more kind of enterprisey things like contracts, governance,
right?
All this stuff. Contracts is an interesting term. I like it in spirit. I kind of feel like it's along the same lines of data governance, or maybe we need to think of new terms, because I've seen data contracts float around some articles lately in sort of the modern data stack community and some Slack groups. And I have mixed feelings about the word contract, because now it's like, okay, so what are you gonna? Okay, if I violate this, what are you gonna do about it?
I mean, at the very least, I get to know, right? And and that's good, right? Like just knowing that the contract is violated is nice, because I'm not going to report this to the CEO. But ultimately, you're right. Like the only thing I can do is go cry to mommy.
You tell my mom?
Yeah, exactly.
Yeah.
And say like,
or your mom,
your report is, not doing this thing that they said they were going to do. Can you please fix this?
Right, but without good alignment, though, it's like, wow, cool. Now you just like make me do more work. And,
totally.
Calling me out with a stupid contract, and then I'll go tell it to your mom actually about this too. So,
but let's talk about some very concrete examples. I mean, actually, all kinds of stuff like this has gone on in the ad tech space, and probably still goes on, where you get charged. I get charged for clicks based on data, and many instances have come out where the attribution was incorrect or other aspects of the data were incorrect. And the downstream people did not find out about this. They just got charged the money, but incorrectly. It was basically fraud. I mean, so that's an extreme example of a supposed contract. In fact, there are actual
legal terms
tied to this.
Yeah, because it's external. Yeah.
And it's violated behind the scenes. And so you're basically getting robbed because of these broken data contracts. And that can happen internally to some extent too.
Totally. Yeah. That's another really good example of you can violate actual law and break your legal contract in addition to breaking data contracts.
Yeah, those are enforceable.
Yeah, that at least, but only enforceable if the hurt party can figure out that something has happened,
and you have to prove it. Then.
Yeah, good luck. You're gonna get a subpoena on Google's internal servers and figure out all the stuff.
Good luck with that, man.
Yeah, exactly. So I think the best we can do is try to guarantee this to our consumers as best possible.
Yeah. I think just having a better spirit of cooperation too, goes a long way. Data engineering, say, and ML engineering, and data scientists and analysts, let's all just live in a world of peace and harmony. And same with software engineers. Let's live in a software 3.0 world. Just, it's kumbaya and stuff.
I was gonna say Joe's out here singing kumbaya already.
We've got Chris Tab, by the way. What's up, Chris? He's gonna be on next week. He's hilarious. Have you met Chris before?
I don't think so.
He's a character. He's really cool. He's out of the UK right now. So anyway, a regular on the Friday show.
Okay, so he's not gonna come and sit with us in the house.
We'll try to get him out.
That would be really hard for him to do. Yeah,
his last trip we really tried, but somehow he went to Canada or something instead. I don't know.
Yeah, it happens. It's probably a cooler place anyway.
Yeah. So let's make things controversial, though. Let's inject some interest into this by talking about data mesh. Because
oh wow, okay,
that's me one of those kind of parties.
All right.
Well, but I mean, it's a different notion of a data team organization structure, and at least one of the ideas of data mesh, from my perspective.
Oh, can you let my dog in real quick? Sorry.
We'll keep talking. Is that you are trying to close that gap between the application side and the analytics side, but at the expense of fragmenting your data team. So you don't have centralized data science. You don't have centralized analytics. Everything is now fragmented into these small domains. I mean,
the 1990s word for data fabric, data mesh was data silo, right? And that was the original. And then, okay, so we have our data lake, oh, great, everything's centralized. It's obviously going to be perfect now. No, you have a data swamp. This stuff isn't actually usable. There's not enough communication between producers and consumers. So you don't have a very good idea of, are the things that I'm saving in this data lake actually useful?
Yep.
I think the thing that appeals to me still about data mesh is purely from a technological perspective. I don't think that there is a perfect database. I think different tools function very, very well for different applications, right? Like we've got stuff like Presto or Spark SQL, like really good when you've got your data lake already set up, where you've got like all of this data spread out. You care somewhat about how fast it returns, but you're like dealing with analysts, not with like applications, right? And then conversely from that, you've got databases like Druid, like ClickHouse, like Apache Pinot, that are really designed to be able to serve people in under a second, right? And like really application performance speeds. And there's all of this talk of trying to like bridge this gap and trying to like come up with the perfect thing for all possible applications of data. And my hypothesis is there is no such thing as a perfect database because of the cap theorem, right? Because like ultimately there are very hard trade-offs that you have to make no matter what.
Although, if you're interested in an episode on one database to rule them all, please check out the Data Nerd Herd episode with Jordan Tigani, the creator of one of the creators of BigQuery and chief product officer at Single Store. Anyway, continue.
let's go.
I'm sure it's a cool database.
It is a cool database. Yeah. I mean, let's loop back too, because it's not just the cap theorem; it's also just costs, right?
Yeah.
Like if you stored all of your data, just in RAM. It's going
to be a really fast database.
Yeah. If you have the budget of the NSA or the federal government, you might be able to get away with that for certain specialized applications. Interesting. One concept Joe and I have bandied about is that you have kind of one front end, but then you have auto optimization behind the scenes. You think of everything as a cache, and so infrequently accessed data just goes down to cloud storage somewhere.
Sure.
And it takes a while to return, and then data you're hitting all the time gets moved into some other optimized.
Well, we're kind of nerding out on the idea too of it's a database where it would just produce certain shapes depending on the use case. And so like it's an interesting idea. Then but they're kind of like what Starburst and Trino's doing too, where you sort of invert it and you just pull everything in as needed. I think storage is always the issue if you have lots of data though, right? So I don't know. I'm sure Web3 is going to solve this.
Of course, and like put it on the blockchain. It'll be faster, it'll be cheaper, and it'll be public. And that's what we want with all of our data.
Yeah.
Right.
The only way to get decentralization is just to let it all free, man.
That's right.
So,
that's right. Just send it out into the universe.
No secrets in the world.
That's right. No more PII. That's great. Oh my God. Immutability. What a useful thing for all data all the time. What you guys are talking about, by the way, the idea of having some things in cloud storage and some things cached at a more front layer. That's something that I was working on at Imply right before I left there, is a collaboration with the people over at Starburst. And this has kind of morphed into a project with Apache Druid called Shapeshifter, which takes into account this some things that you want to be stored on your edge database, on your really fast performing database, other things you want to just store in object storage, and being able to, it's a very hard problem of figuring out
it's really hard.
How are people going to be accessing this data? Yeah. When do I want this data here? But this is really actively being developed. But I still don't think, this is solving it for analytics versus
transactions.
Exactly.
Yeah.
What about for machine learning, right? We want things in feature stores. We want nicely tailored. There's a different set of requirements for different types of consumers. And that's why I think data mesh is still a valuable thing. There is, of course, always going to be problems around data siloing, around lack of consistency between different teams, and that can have really negative downstream impacts. But again, this comes back to people and process before technology, right? Making sure that you've got the right systems in place to be able to ensure your data mesh doesn't turn into data silos.
Right. And also the incentives are there so that my team, if I'm working on some corner aspect of the web app, say I'm working on, the customer service app. Okay. So online retail, make sure the customer service needs are met. Do I have an incentive to provide quality analytics data, not just the analytics data that I care about, but the analytics data that the machine learning team cares about, the analytics data that other analysts care about, the analytics data the CEO cares about? I think the incentive problem is a hard one to solve, but if you can solve that, then your business is going to be way, way better off.
And that's why you got to bring in Aaron Hunziker.
Yes, exactly.
To figure out how to align your team's incentives properly.
We're going to start having Aaron Hunziker as a service. So that we can, sorry, Aaron, it's since we've decided what your next role is going to be. We're going to have him on in a week or two for this, and we can talk about economics of data. We'll have lots of
that sounds sterling.
Economics
it will be if he's talking about it.
Interesting.
Okay, so you guys have been interrogating me. I've got one ready to go for you guys.
Okay.
Can I ask you guys a question?
Go for it, man.
Why do you guys hate machine learning?
Who said we hate it?
Recovering data scientists.
We're trolling. Okay. It's true though.
He comes out and says it.
No, it's true. I think both of our backgrounds, we both had these experiences in various jobs where we really enjoyed the data science, but it was extremely hard to get anything done.
Yeah.
Because in many cases we had data engineering teams, but the incentives were not aligned. Like just stuff wasn't getting done correctly to do data science. So when we say, I think the idea of recovering data scientists is to say, we can't all be data scientists, right? Like it actually, that gets nothing done. And I think a lot of that is still going on where everyone wants to be the machine learning engineer or the data scientist, and these other core problems aren't always getting solved. And you discover that if you go back and solve those core problems, there's a lot of value there before you even ever get to ML. And then if you can build ML on top of that, the value is way, way higher.
Yeah, we just kept seeing people, I think, and this is more true in the kind of the mid 2010s, early 2010s.
I remember the time period you're talking about.
Yeah, exactly. And sort of, kind of later on, but
the
data science, sexy job.
Yeah.
And it's just kind of dumb, really. I wouldn't say dumb, but I think it was premature.
Yeah.
We'd often see situations where there was a lot of overhype, like, no data foundation build. It's like, we need to do AI, we need to do ML. Hire a bunch of data scientists, hire a bunch of math PhDs like Matt, hire me or whatever. And every time we'd go in, it's just like, cool, where's the data? And like, well, we don't really have that either. So I realized a lot of the problems are just engineering problems at the end of the day is with production, right? And I'm sure, your co-founders, I think, saw the same thing. And just, they're great engineers and, production ML is hard, right?
Yeah.
Like it's really damn hard. It's easy to do it on Jupyter.
Yeah, I mean,
notebooks.
even at Amazon, it's hard.
Yeah,
let alone at any other
company, which is where I guess is really hard. So I think that's why we call it call ourselves recovering data scientists. I think it was like maybe I can't remember if it was Dave Gonzalez or Ben Taylor. Or we started calling each other like a kind of reformed data scientist. And, then I was like, I'll just go into recovery on this. So I think it's kind of where it came about. But it's more of a tongue-in-cheek joke. But there's an article on my LinkedIn if anyone has questions about why I called myself that. Because I got so many questions, and when I first announced it, they're like, "Why would you do that? Like,
why do you hate machine learning, Joe?"
I love machine learning. I love ML.
He also hates pandas.
Oh yeah,
not the.
I was gonna say the Python library.
The animal,
because it's single node, or.
No, but I mean that's kind of the gist of it, I think. And when I met Matt a few years ago, I was kind of like, he's on the same wavelength, so which is kind of rare because I think a lot of people are buying into the data science Kool-Aid. I see it less and less though, right? Like the whole MLOps, the whole ML engineering movement, I think it's definitely a sign of the maturity in the space. But for the longest time, it was just like, cool, have fun, doing that.
Yeah.
So I think we're just earlier to it more than anything, and just got to see a lot of the pitfalls. But
I would say like Google actually was one of the first companies to come to this conclusion. They just don't advertise themselves this way. Like Google, I would say, pitches themselves as a quote unquote AI company. Mm-hmm. But if you look at it, they were the first company to a lot of these data engineering innovations.
Yeah,
they recognized
hidden technical debt in machine learning systems is like the thing that launched most of these conversations.
It is. I would say it's a pivotal paper for sure.
Yeah. They're a data engineering company, and that's why they're so successful at quote unquote AI, because they have all those foundations in place.
Right. Okay. So would Google have been successful if they just wrote everything in like notebooks?
Exactly. Probably not very well in the early days.
Well, so okay, let's talk about notebooks. Netflix is like productionizing Jupyter notebooks.
But that's the point. They're productionizing. Right?
Yeah. Okay. You're right. Like it does get to production.
And they figure out a way. And I've kind of mixed feelings.
It's not just like a raw Jupyter notebook.
Yeah, but I have kind of mixed feelings about how they did it. But obviously they made it work really well, and I'm not going to argue with that. Success is success. So.
Yeah, I have.
If they could stop recommending like movies I hate, then that would be great too.
Well, I mean, if they were monitoring the machine learning models a little bit better.
Yeah, geez, Joe just like scrolls and then leaves the app all the time. I cannot find anything on there. This happened last night actually. So I was watching a couple episodes of Space Force with my kids. I was like, never mind.
It's really dumb. I couldn't handle it anymore.
Let's say Ed Mitchell. What does he say here? ML seems fun, but he's seen so many cool projects get thrown out or creating scores that no one trusts. Yeah, happens a lot. Let's talk about the last part though, right? Creating scores that nobody trusts.
This is another organizational problem that I've seen. In some cases, you have competent data science, but business leaders are like, oh, well,
that doesn't agree with what I want.
They'll just like manually, Google tells you in Google Ads, do not manually tweak bids unless you really, really know what you're doing. Let's like go in and turn them off.
Right. But I don't think that this is necessarily like just a machine learning problem, right?
Yeah.
Like
Yeah.
I've seen this at like,
Yeah.
you know, I got into consulting, like MBB, like management consulting for a brief period of time. And a lot of my friends in that world were like, yeah, basically what I do is an executive has come to a conclusion and now wants to bring in McKinsey or BCG or Bain to be able to justify that conclusion for them. So like they know what the
Yeah.
answer is, and usually they're right. Like, right? Like these are like intelligent, intuitive people who have a lot of exposure, but like they need somebody else to come in and do the data work for them.
Yep.
But I can definitely imagine situations where they're wrong, but still like the data analytics comes as justification for things instead of as the reason for things. But it's also true like organizationally in machine learning as well. That yeah, if you like build a perfect machine learning model, but you don't get buy-in in your org, it doesn't matter what you build. It's bad.
Well, I think it's important
Mhm.
to recognize that there are decision-making patterns that block data-driven patterns.
Mhm.
So in other words, if someone is going in and manually editing spreadsheets that are really complicated, that's kind of an anti-pattern, because
Yeah.
you just, as a human, you can't operate on the data at the same scale that
scale.
a machine can.
Right.
So an executive needs to be making strategic decisions like, okay, what kind of margins are we targeting, for example? That might be a strategic decision. Getting down into actual bidding, that's more of appropriate for a machine decision, I feel like.
I completely agree.
Yeah.
And I think this is getting into augmented intelligence, which is
Yeah.
something that I like love thinking and talking about. This idea that like human beings are good at some things, machines are good at other things. And we shouldn't be thinking about machines like taking our jobs or taking over the world for the most part, because until we achieve like true general AI, which maybe it'll happen in our lifetime, but like, I don't know, like possibly not. For at least a long time, AI is going to be really, really good at very specific tasks.
Right.
They're going to
Right.
keep beating us at chess. They're going to keep beating us at Go. They're going to be really good at recognizing images. And importantly, like, you know, computer time is a lot cheaper than dev time. Like human beings are cheap compared to processor time. I'll say that like one really cool example that I love for augmented intelligence is obviously humans have been losing to computers in chess for kind of a long time, right? Since Deep Blue. Turns out human plus computer outperforms computer quite a bit. And this is called Centaur chess, right? And what's interesting is the best humans in Centaur chess are not the best human players. Like obviously, you know, they're better at chess than I am, but they're not like the ultimate grandmasters at chess. And the reason for that is to be an ultimate grandmaster at chess, you have to play like a combination of a human and a computer. You have to know both the high level strategy and the individual tactics and be able to compute like 40 moves ahead, right? But if you are a human who's playing in the Centaur game, then you don't have to think like a computer at all. You only have to think strategically and like a human being. So your skills are different.
I was making an echo.
Oh, sorry. I'm gesticulating really wildly on the table.
No, this is fascinating. I mean, there's also this notion, and does this come out of Google originally, of decision science? We start seeing a lot of advocates for.
I think it's
science.
popularized by Cassie. I can't remember her last name.
The decision scientist.
Yeah, but I don't think it comes from that though. I mean, decision science has been around for a long time.
But is the future of decision science this kind of augmented approach where the human is involved in the strategic decisions, but not involved in like every little manual tweak of what's happening with the business?
Maybe. I don't know. I had a debate with somebody about decision science. I mean, I have kind of mixed feelings about it too. Because I remember this person talked to me and said, "Oh, the stuff you guys talk about is like just old hat." And,
Oh, I know who you're talking about.
yeah, I just said like whatever. So, I mean, I didn't buy the argument at all. So I just kind of let it be. So
I agree with Matt. Like, I think like the thing that's branded decision science is going to be really key for making strategic decisions. And I think decision science is just like taking data analytics and data analysis and giving it a sexier name, right?
yeah, I mean, how's it any different than like just making
being an
decisions
analyst,
with
like being a BI analyst, right? The difference is like decision scientist, like, oh man, that's a cool title. Like I want to have that title.
Yeah.
So like it's doing a good job of moving away. You know, there was this period in like the mid tens, like the teens, where everybody was a data scientist, right? Like BI analysts using Tableau and like Snowflake, we're data scientists. This is like a wild situation to be in because the term got so overloaded that it was useless. Now we're like starting to see, you know, machine learning engineer, machine learning researcher for people who are doing machine learning. We see like decision scientist and data analyst is becoming not as stigmatized of a word. But I think that's a lot of what decision science did is it took this idea that data science was the sexy job of the 21st century and said, okay, how do we like tweak this so that we're not overloading the term.
So I can
data
get some of that
scientist.
credit too.
Yeah, exactly. I think
yeah.
that to me is what I see decision
I had a
science.
quip. I think it was data science is neither. So I'll let you think about that one for a second.
Sorry, data science is neither?
Yeah.
Like neither ML nor
Yeah,
analytics?
just neither data nor science.
Oh.
So I
Yes.
got it from this little bumper sticker that said sport climbing is neither.
At the front, I assume.
No, this is back in the day. Over
Okay.
at Waco. It was my old friend John Sherman, actually, the guy who invented the V scale, actually.
Oh, interesting.
Yeah, but he came up with that 'cause he didn't like sport climbers. Anyway,
And you don't
It's
like data
controversial.
scientists.
I like data scientists. He wants to get like some curmudgeon or something. He hates everybody, but I mean, I got a dog, I got friends.
Friends.
Yeah.
You're paying us to be here.
Yeah, true. I bought you lunch. So it's a pretty cheap date. So, but no, it's. I mean, I'm interested to kind of see where it kind of goes over the next few years too. Decision science, I think it's. I dig it, but to me, it's no different than like using data to make decisions. Which I mean, that's kind of how you have made decisions. Strategy and decision making has been around for a very long time.
Right.
I mean, there are countless books in it, and Peter Drucker sort of championed modern strategy as well as other thought leaders of the 20th century. And so I guess I don't see a lot new in it.
Yeah.
But
I mean, I think the scale is different, right? Like that's one component is like we do have access to like literally more data and data about more things. But like you're right, like fundamentally, it's still data.
Yeah, exactly. More data doesn't mean you're going to make a better decision. It just it might make you just help like do dumb things more quickly or more at scale.
Right.
So which is entirely possible.
It's
actually,
cool on your resume.
It's cool. Yeah, I mean, I like I want cool titles. So Matt wants one.
I mean, the other thing about data is that's kind of a local optimizer, right? Like you optimize the business as it is now.
For the data that you have.
For the data you have, right? So if you're in online retail, data, it's much harder to go from being an online retailer, maybe getting into a fundamentally new line of business versus just tweaking item prices and recommenders in online retail.
Yeah.
And that's maybe that's what we would call decision science. It's like, how do you decide to get into a new line of business? How do you decide you're actually going to be competitive against other players? And how do you decide that there's a moat there that you can do something unique in this space?
I mean, to me, you still make that decision from data as much as you can, right? It's different. Like it's not your user data. Like this is actually something that came up really recently for me. So I was talking to a candidate for a position at WhyLabs, and we were talking through like how would they make certain decisions, and his answer is like really customer centric, really data driven. This is like quite a good answer, right? But it's missing half of the puzzle, right? If you're only looking at your existing customer base, you're suffering from survivorship bias, right? Like you're only looking at the planes that came back. You're not seeing all the planes that went down, and you're not able to make decisions moving beyond the local optima that you've already found.
Well, especially at an early stage startup too, you have to be thinking about what the opportunities are that don't yet exist. Right. So if your data set's really small because you're early, then it's like, well, we'll get optimized for like a grand total of this many customers.
Yeah.
And so, and it's a big problem. I mean, part of it, I think, is like, I look at what Sam Walton did with Walmart back in the day. I mean, he started that in Arkansas, had some kit stuff. I think he used to be a Ben Franklin store of all things back in the day, but he, I think had a very good strategy, or it was very anecdotal though. It's like, let's go to small towns and bypass, the big cities, and then we'll finally surround the cities in the end. And that's exactly what he did. And he killed it. And I think, but that was based on gut, I'm sure. He was, Walmart was one of the first data centric companies too, to give him credit. I mean, they invested in, in the 80s in more supply chain and logistics software, I think any other company did. And I think at one time, I did a lot of work with them as a supplier, and it was like their infrastructure, their data was insane. It was great. Yeah. So good. I think they had a bigger system than the Pentagon did.
Wow.
Yeah. This is back in the 2000s. So a lot of great data.
Yeah, that's the kind of problem that like you
can't solve from
your existing data. And then all the time we see this. I mean, if you worked at a startup, you've seen startups like chase their existing customers. In other words, one of their customers like, hey, can you add this feature? It's like, it's going to be a lot of developer time. Okay, we'll do it because obviously it's important, but it may turn out that it's not important for anyone else external.
This is definitely a big problem. It's like product companies turned into like services companies effectively.
This happens a ton. It's a big trap.
A
really big trap.
And
be careful.
At what point in scaling to go back to? So presumably, like Sam Walton was kind of looking around the world, these rural areas, like, okay, how well are these served by retailers, and had some ideas. At what point did he go and collect data? I assume it's
well, his way of collecting data was like he would take his plane and fly over the parking lots. I'm not kidding. He would do this, you know, and just see like how's Walmart doing compared to everybody else. I mean, the guy was super far ahead, but you know, in days where data collection was just harder because it was very, you know, just cost. You know, now you just do it with a drone or something, but he has to take his plane. But more power to people like that, I think, because he is just very forward thinking in terms of
such a
business.
bootstrappy thing to do. That's crazy.
The guy's punk rock. Like you think Walmart's just it wasn't always a big, you know, company. I mean, it was, you know, it was a startup at some point too.
Wow.
In the most like backwards place, Bentonville, Arkansas. Like you're Benton. Now it's cool, like because everyone goes there because it's Walmart. But back in the day, I can only imagine it's like
trying to never have Walmart as a customer.
Anyone wants to work with us, sure. But but it was crazy though. You know, like Arkansas it's kind of just you know, it is what it is.
Yeah, they made a city. Like they built a city around it.
I mean, that's cool. But that's testament, I think, to just being scrappy and just, I think, identifying opportunities before a lot of people do. And so it's interesting nowadays. I think we're kind of talking about this with arbitrage. Earlier before we started this, because we're talking about arbitrage
and Ethereum blockchain, right?
Talk about.
But we found I think it's really interesting just because now I think there is a lot of data, but a lot of it's accessible to people. So how do you get an edge? Because I think we're talking about trading and just how do you have an edge? Most modern finance, really, it's impossible to get like that high of an edge on people, right? Because all the information's like pretty standard. I was kind of joking. Well, if you're on Wall Street Bets, like people there, do you think you have like an informational advantage over like traders who do this all day?
I mean, they had a concerted effort advantage, right? Like it was basically a mob movement.
Yeah. So.
I mean, I think this is getting a little bit abstract, but also tying it back to machine learning.
Yes,
it's Friday though.
I got it. I'm doing it. So you can have like a data moat, but you can also have a model moat, right? And this is what Rentech does, right? Like they like basically figured out like, okay, we're just going to hire a bunch of math and physics PhDs who studied similar related things to the way that we think markets operate based on Brownian motion. And we're going to figure out some edge. And the Medallion Fund seems to perform really well, maybe based on like at least what we can see publicly. So there is some way to take public data and be able to process that data better than other people. But I think this like model-centric AI approach maybe doesn't apply in a lot of other situations where it really is data that gives you a differentiator.
Well, especially in the days of like AutoML or AutoMLOps. But no, I mean, because you're just applying pretty standard techniques, maybe in its own way, to its parameters a certain way. But at the end of the day, it's off the shelf. And the thing is, for a lot of people, I think, you know, you got to think of ML as just what's good enough for what we need to do.
That's right.
You know, for most cases, Congress people apparently do. Whoops.
Because in general, most companies have a lot of opportunities that they're not yet exploiting, right? That are low-hanging fruit. I mean, even Facebook probably have opportunities they haven't identified yet, but presumably they've mined a lot more of those opportunities. But I think most of the customers we talk to, there are all kinds of opportunities using fairly basic modeling techniques.
But I would say in a situation like this too, where modeling techniques and data is pretty standard, like maybe one of the best approaches is to kind of zig where other people zag from a strategic standpoint, right? So, because I think the danger of ML is it homogenizes everything, and you're sort of seeing this happen. I mean, I think the world. Recommenders are very boring in my opinion. They curate just enough to make it seem slightly interesting, but when you look at under the hood, you're just like, this is the same. The more I participate with content, the more of that content I see. There's not a lot of serendipity left. And so, you know, in terms of, you know, whether you're a business or whatnot, I would say definitely look for different ways of doing stuff that maybe you can take advantage of, just because everyone's attention is going to be exactly what the algorithm's telling them to go. Like, so if you had half a brain and you're just competing against people, you'd be like, cool, keep doing that. We'll exploit these new opportunities over here that you know, not isn't being noticed by the algorithm until such time the algorithm notices it, then
catches up. But
then you just switch paths. So it's interesting.
But again, like algorithms tend to be local optimizers, right? They just optimize around the business.
It's a really good mental model. I've never thought about it that way, but I think that's a really good way to think about it.
Like a local minimum, like what's next?
Right.
Here's what we're doing now. All right, if I move over here just slightly with recommenders, improves.
Well, it's like think globally, maximize locally or minimize locally.
Yes.
Jeez, we're nerds. Yes, we are. Cool. Probably a good time to wrap it up. Thanks to the audience for joining us in this very
How do you build
spontaneous-
serendipity into a model?
Oh, well, it's about to close out, but we're gonna go to Mark Keeling. He's always got good questions here. So how do we build serendipity in a model?
I mean, this is super real in like exactly in optimization theory, right? Like stochastic gradient descent has stochasticity built into it. Like a lot of systems will intentionally build in some amount of noise as a way of being able to explore a little bit more globally rather than purely optimizing locally.
For sure.
Yeah, and with like really classical statistical optimization techniques, you decrease the amount of noise that you're introducing over time, so that you're getting back to what you think is probably the global maximum.
So in other words, you kind of find the global maximum, and then you really dial in on that.
Exactly.
Turn down in some sense, the learning rate. Right. So
it's the explore-exploit trade-off in optimization.
Mm.
So hopefully that answered the question.
Of course, there might be other ways, though, right?
Yeah. Just turn the model off. Go hit shuffle, and there you go.
Yeah, that's also a way.
That's also a good way. Although turns out people are very bad at identifying randomness. So so Spotify's randomness is not based on an RNG. It introduces some amount of intentional novelty, because otherwise you would hear the same song repeatedly.
Yep. Yeah, their radio, I use that often more to kind of curate stuff. They have a really good discovery mechanism.
They do.
Yeah. Because they don't just base it upon song titles. It's also based on tonality and other elements of the actual audio track.
And the social component.
Yeah.
What other people like you. Yeah, exactly.
Yep. Exactly. So what else do you say here? Sorry. Seems like when models get the exploit portion of the equation, that is when Netflix gets boring. Yeah, they said get back to me last night when I was scrolling through it. I was like, there's nothing to watch.
But this is okay. But Netflix is another example of this big business problem of local optimization versus strategic decisions. Netflix has this whole department, a massive department that is looking for new content and trying to sign new deals. Those are really high stakes decisions.
Yeah.
What's that?
And producing it themselves.
And so you're talking these $100 million deals in some cases that are made in a very traditional way. It sounds like, but it's mixed with data, right?
There's a ton of data
cards.
into it.
Yeah. So if only in Curb Your Enthusiasm season 11, if they had just taken Larry David's show.
This is the one I watched the first episode, right? I haven't seen the rest.
If anyone wants a really good, just a good watch, just check out Curb Your Enthusiasm season 11 on HBO Max. It's hilarious. So the whole thing is around Larry David trying to sell a show, and anyway, he in the midst of that gets blackmailed by somebody who wants his daughter, who cannot act, to save her life. He forces her to become part of the show. So centers on that. It's pretty funny. But anyway. Oh shit. Okay. So better get going. I think it's my kids are here. All right. All right. See you guys. Bye.